Welcome to Maths with EJD. In this video, I'll be talking about Markov chains with a worked example on weather prediction. In the previous video, I talked about the basics of Markov chains and some real-world examples, and we saw how very applicable Markov chains can be. So let's go ahead to start with a problem setup, just like the example I gave in the previous video. So we have two possible weather states. So it's either sunny, S, or rainy, that is R. So the next thing is that we have the Markov property such that the weather for the next day depends only on the current day's weather. On the current day's weather. That's the Markov property. The weather, the state of the weather before today, before this present day, does not matter. Okay. Now the transition probabilities are as follows. So first, if it is sunny, there is an 80% chance that it will stay sunny the next day, and a 20% chance that it will become rainy. Okay. So again, if it is rainy, there is a 40% chance that it will become sunny and a 60% chance that it will remain rainy. Okay, so the next thing we want to do is to say we can represent this using the following transition matrix. Okay, the transition matrix, let's say it's T. So that means T is the probability it's sunny today and it's sunny tomorrow. Probability that it's sunny today and it's rainy tomorrow. Probability that it's rainy today but it's sunny tomorrow. Probability that it's rainy today and it remains rainy tomorrow. So you can do it like this is sunny, rainy, sunny, rainy. So sunny to sunny, rainy to sunny, then sunny to rainy, sunny to rainy, rainy to rainy, like that. Okay. So with that now, we already have all of those. Sunny to sunny, we're told is if it is sunny, there's an 80% chance. There's an 80% chance that to stay sunny. So sunny to sunny is actually this T. Sunny to sunny is 0.8. Sunny to rainy is 0.2. So if it's sunny today, it's rainy tomorrow, the chance is 0.2, as we see here. 20% chance that it will become rainy. But if it is rainy, there's a 40% chance, 40% chance that it will become sunny. So rainy to sunny is 40%. And this is this. So 0.4. 40% is 40 over 100. That is 0.4. And a 60% chance that it will remain rainy. So 60% chance that it is going to remain rainy is 0.6. So this is the transition matrix. Is the transition matrix for the system. Zero, all that. So a 2 by 2 matrix for that matter. Okay, so you have a 2 by 2 matrix there. Now, the next thing we want to talk about is okay, um, okay, let's establish this. Let's say today's weather, today's weather is sunny. So that's like our where we are starting from. Let's say today's weather is sunny and we want to calculate, we want to calculate the probabilities, the probabilities for the weather over the next few days. Okay, so what steps do we take? First of all, let's take step one. We need an initial state. We have to define the initial state. Of course, based on what we have, the initial state is that today the weather is sunny. So we define the initial state as x naught. Okay, representing the probability distribution of the weather on day zero. Okay. Since we are certain that the weather is sunny today, is sunny on day zero, that's where we are currently at. Of course, the it may also be certain that maybe you can have a 50% chance and things like that. So you can actually work with what you have. So since you're certain that the weather is sunny today, so that means our initial state, which is x naught, can be given as 1, 0, okay, which is a 1 by 2 matrix. This is a 1 by 2 matrix. So this simply means, so of course, this is now like sunny, rainy. So what we are sure that it's sunny today. Of course, it depends on whatever probability you have, it can actually x naught does not have to be 1, 0 all the time. Okay. But that's what we have for now. So this means there is 100% chance of it being sunny and a 0% chance of it being rainy. I mean, this is a rare situation, right? Sometimes you can have like 80% chance that it is rainy and all that. So, this we are just taking this in this situation. Okay. So let's go to step two. Since you have established the initial state, the next thing we want to do is to calculating the weather probability, the weather probability on day one. So after day zero, what's the probability of day one? That's to be sunny or rainy and all that. So to calculate the probabilities for day one, we multiply the initial state by the transition matrix. Okay, that means we have xi bar equals x naught dot t, which is t is the transition matrix as we already know. So that means we have 1, 0 multiplied by 0 0.8, 0 0.2, 0 0.4, and 0 0.6. And if you remember, if you check my matrix playlist, I already gave a very good way of dealing with this. So, this row, let me use something bigger. So this row, I mean, this column, right, will be multiplied by this. And this one will also be multiplied by the same thing. So that we have, of course, if we multiply a 2 by 1 matrix, or rather, this is a 1 by 2, one row, two columns. So 1 by 2 matrix multiplied by a 2 by 2 matrix, if you cut this out, you're going to get a 1 by 2 matrix at the end of the day. So one row, two columns. So that simply means we're going to get 0 0.8, 0 0.4 multiplied by 1, 0, and then 0 0.2, 0 0.6 multiplied by 1, 0, so that x1, the the probability for the day one is going to be 0 0.8. This is 0, this is 0. So you have 0 0.8, 0 0.2. So that is x1 bar, okay? So what this simply tells us is that, I mean, we can say, so after day one, right? After one day, okay, you can say there is an 80% chance of it being sunny, whereas there is a 20% chance of it being rainy. It's been rainy, okay, and that goes. Then we can talk about step 3. Step 3 now. Okay. Step 3. So now I want to calculating the weather probability on day 2. So what do we get? Now we need x2, which is the same thing as x1 times the transition matrix. So the transition matrix remains the same, but the x i's continue to change. That's the states begin to continue to change. So the weather on day 2 is going to be determined by the weather on day 1, not no longer weather on day 0. That's the idea of the matrix property. I mean Markov property. So x1 now we know is 0 0.8, 0 0.2 multiplied by the transition matrix 0 0.8, 0 0.2, 0. Whereas this is 0 0.4, 0 0.6 down here. Again, what are we going to get? It's a 1 by 2 matrix multiplied by a 2 by 2 matrix. So we get a 1 by 2 matrix. So this is 0 0.8, 0 0.4 multiplied by 0 0.8, 0 0.4. That means this multiplied by this. That's what has happened there. And the other one now, you have 0 0.2, 0 0.6 multiplied by 0 0.8, 0 0.2. So it means that x2 is simply going to be 0. So this is 0 0.8 times 0 0.8 is 0 0.64 plus 0 0.4, 0 0.4. That is 0 0.4 times 0 0.4. Oh, okay. This is my mistake here. This is 0 0.2 actually. So 0 0.2. Okay. So 0 0.4 times 0 0.2 is 0 0.08. And here you have 0 0.16. 0 0.2 times 0 0.8 is 0 0.16. 0 0.2 times 0 point this is 0 0.12. So that x2 is simply 0. 72, okay, 0 0.72, and this one is 0 3, oh, 0.28, 0.28. So the state on this of the second day is now 0. So the probability that it will rain on the second day, okay, I mean, we have a statement for that. So after 2 days, after 2 days, there is a 72% chance of it being sunny. And then there is a 28% chance of it being rainy. Okay. And then we can go again. Step 4. So for step 4 now, calculating the weather probability, the weather probability for day 3. For day 3. So that means we have x3 equals x2 dot t, the translation matrix. So, and from what we have already, x2 is 0 0.72, 0 0.28 multiplied by 0 0.8, 0 0.2, 0 0.4, 0 0.6, so that now, of course, we expect to have okay, 0 0.8, 0 0.4 down here, multiplied by 0 0.72 and 0 0.28. Then here we have 0 0.2, 0 0.6, then all that multiplied by 0 0.72, 0 0.28. Okay. And then if we do all that together, 0 0.2 times 0 0.72 is actually 0 0.576 plus 0 0.4 times 0 0.28 is 0 0.112. And coming here, 0 0.2 times 0 0.72 is 0 0.144 plus 0 0.6 times 0 0.28 is 0 0.168. So if you sum all of that up, you have 0 0.688, 0 0.312. And this is actually our X3. This is the states after day 3. So we can say that after 3 days, after 3 days, there is a 68.8% chance of it being sunny, and then there is a 31.2% chance of it being rainy. Okay. And of course, you can keep going like that. Of course, with computing these days, things you can quickly get so many iterations, and usually you will see that the whole thing tends to get towards a particular equilibrium. Okay, so of course, you can continue this process, right? Now, how do we interpret the results? Interpreting the results, so you can go as many times as possible. And with computing, you can check what is going to happen like after 100 days. That is why you can have weather forecasting, for several days. Of course, the closer the days, the more reliable, right? So you see that as we move further out in time, as we move further out in time, we notice that the probabilities stabilize. The probabilities of the system actually stabilize. Okay. So over time, the system reaches a stationary distribution, what you can call a stationary distribution. Okay. Where the probabilities of being in the sunny or rainy states no longer change much. Okay. So in this example, the probability of the weather being sunny stabilizes around stabilizes around 68 to 70%. Then the probability of the weather being rainy stabilizes around 30 to 32%. So, so we can have a general pattern. So there's a general pattern we can see. So in general, for any state distribution, for any state distribution, xn bar, xn arrow, we calculate the next state xn plus 1 using xn plus 1 equals xn multiplied by the transition matrix. And then as n approaches infinity, the state probabilities will converge to a stationary distribution. A stationary distribution. To a stationary distribution where further multiplication by the transition matrix leaves the probabilities unchanged. Okay, so there's usually a stabilization of things at the end of the day. Okay. In fact, I think I want to make one more video. I'll write a Python code to demonstrate how this converges. A code will make it converge. So you can see we can play with many states down the line. So you can see how all of these things happen. So expect one more video on Markov chains where I strictly talk about Python to see this stabilization I'm explaining right here. So if you have not subscribed to this channel, you want to subscribe so you can always be in touch with all the things I'll be doing. Of course, hit the notification bell also so you can always get alerted each time a new video is released. And don't forget to comment, like, and share. And then watch out for the video where I'm going to be using Python code to deal with this so we can see how where these things converge to at the end of the day. Okay. See you later. Thanks for being here.